Hello viewers at home, this is Helizchem. Today we want to quickly look at some questions on quantitative analysis which may likely come out in this WAEC 2025 Chemistry Practical. A is a solution containing 1.82 gram of HCl per 500 cm³ of solution. B is a solution containing 2.8 gram of a mixture of sodium hydrogen carbonate and KCl in 200 cm³ of solution. 23.50 cm³ of A neutralize 25 cm³ of B completely. Calculate A concentration of sodium hydrogen carbonate in mole per dm³ in B. B mass of sodium hydrogen carbonate in gram per dm³ in B. C percentage by mass of sodium hydrogen carbonate in the mixture. D mass of KCl present in the mixture of solution B. E volume of CO2 produced by 1 dm³ of solution B. And you are giving hydrogen to be 1, oxygen is 16, carbon is 12, sodium is 23, chlorine is 35.5, and molar volume at STP of a gas is 22.4 dm³. The equation of reaction is given as NaHCO3 reacting with HCl to produce sodium chloride plus H2O plus CO2 gas. Now let's look at the solution. You want to solve for question A, where you are asked to find concentration of sodium hydrogen carbonate in mole per dm³. If you look at the question given, you are given HCl to contain 1.82 gram in 500 cm³. That means you are going to find the mass concentration of HCl. Having it in mind that 500 cm³ is the same thing as 500 over 1000. That's the first thing you will do. You will convert the volume to what? To dm³. Having done that, we have mass conc is equals to mass over volume in dm³. So you are given 1.82 gram over what? Volume 0.500 dm³. And that will give me 3.64 gram per dm³. So this is the mass concentration of HCl. From there, you'll be able to get the molar concentration of HCl. So using molar conc is equals to mass conc over molar mass. But you have to find the molar mass of HCl. So molar mass of HCl now is H is 1 plus 35.5. So make sure you always put your unit in WAEC. Unit is very important in chemistry, and this is what WAEC will mark for you. You have to show how you get your 36.5 gram per mole. So this is where WAEC will mark. Having gotten that, you will now substitute it in the above equation. So therefore now, molar conc of HCl from the above is mass conc over molar mass. which is equals to 3.64 over what? 36.5, and that will give me 0.0997 mole per dm cube. Don't forget, your value should be in 3 significant figure, and you must put correct units. The next thing is to use our equation using CA VA over CB VB, which is equals to NA NB. Then before you complete it, you have to put the mole ratio. If you look at this is 1. Mole ratio of base is 1 and mole ratio of acid is 1. So you have to write it, because WAEC will not mark this. WAEC will focus on this. It is the value that you write here, which is the mole ratio 1/1 that WAEC will mark. Now, you will now substitute all the values here. Don't forget, CA VA over CB VB is equals to NA over NB, which is 1/1. So substituting our values, our CA already obtained is 0.0997 times volume of acid, which is 23.5, divided by CB, that is what we are looking for, and our VB is 25, which is 1/1. For correct substitution, WAEC will give you 1 mark. Now, for making CB the subject of the formula, you will get 1. Recall that CAVA over CBVB is equals to NA over NB, which is equals to 1/1. As I said earlier, this is what WAEC will mark for you, 1/1, not this formula. So it is very essential that when you are writing your formula, make sure you complete it by putting the mole ratio. Then substitute the values. CA is 0.0997 times VA, which is 23.50, divided by CB that we are looking for, which is the concentration of the base, times volume of the base, is equals to 1. This also attracts 1 mark. For correct substitution is 1 mark. Then making CB the subject of the formula also attracts 1 mark, and we have 1 times 0.0997 times 23.5 divided by 1 times 25. Then the final answer will also give you 1 mark. So if you press the calculator now, give us 0.0937 mole per dm cube. Don't forget 3 significant figures. Now to question B, which says calculate the mass of sodium hydrogen carbonate in gram per dm cube. We are using this formula which says molar conc is equals to what? Mass conc over molar mass. So you have to find your molar mass of sodium hydrogen carbonate. Like I said earlier, you have to show how you get it, because that is where WAEC will mark, and you put your unit, and that gives us 84 gram per mole. Therefore now our mass conc, because we are asked to find mass of this in gram per dm cube, automatically we are looking for mass conc of sodium hydrogen carbonate, and that one will be equals to molar conc times molar mass, and this is equals to 0.0937. That is our molar conc that we got earlier, which is 0.0937 times 84, and that one will give us 7.87 gram per dm cube. So that is the mass of sodium hydrogen carbonate in gram per dm cube, 7.87 gram per dm cube. Question C says calculate the percentage by mass of sodium hydrogen carbonate in the mixture. So to find that, we are going to use this formula which says percentage by mass of sodium hydrogen carbonate now will now be equals to mass of sodium hydrogen carbonate in the mixture over mass of mixture itself times 100, because we want to calculate percentage by mass, so it is multiplied by 100. Let's substitute our values. We know the mass of sodium hydrogen carbonate already calculated, but we have to find mass of mixture. Mass of mixture. How do we find mass of mixture? Don't forget, we are given that B, which is the mixture of hydrogen carbonate and what? And KCl, contains 2.8 gram in 200 cm cube. So you have to find the mass that is contained in 1000. How do we get that? This implies that 200 cm cube contains 2.80 gram. Therefore, 1000 cm cube will contain 2.80 over 200 times 1000. And when you press the calculator, you have 14 gram. So this is the mass of the mixture. We will now go back to our formula, which says that percentage by mass of sodium hydrogen carbonate will be equal to what? Mass of sodium hydrogen carbonate over mass of mixture times 100. So let's substitute our value. We now have 7.87 over 14 times 100. We have 56.25%. 56.25%. So question D. Question D is asking us to find mass of potassium chloride present in the mixture. For you to find the mass of potassium chloride in the mixture, you have to note something. Note that mass of mixture contains mass of pure substance plus mass of impurity. So when you have a mixture of substance, So the whole mass is a combination of the pure substance and impurity. Therefore, we can say that mass of KCl present is the same thing as mass of impurity. So automatically they are asking us to find mass of impurity. So we are going to use this formula. Our mass of mixture, therefore 14 will be equals to what? Mass of pure substance that we calculated was 7.87 plus mass of what? KCl. So to get mass of KCl, it will now be 14 minus 7.87, which is the same thing as 6.13 gram. So 6.13 gram is the mass of KCl present in the mixture. To question E now, E says calculate the volume of CO2 produced by 1 dm cube of solution B. How do we go about it? You want to recall that from the equation, 1 mole of sodium hydrogen carbonate produced 1 mole of CO2. This is the equation. If you have forgotten, this is it. Sodium chloride plus H2O plus CO2. So this is ratio 1 to 1 to 1 to 1 to 1. So from this equation now, 1 mole of sodium hydrogen carbonate produced 1 mole of CO2 gas. But we all know that 1 mole of a gas at STP has a volume of 22.4. That is why you are given the molar volume of gas to be 22.4 underneath the question. So from here now, this implies that 1 mole of sodium hydrogen carbonate produce 1 mole of 1 mole of CO2. And we know that 1 mole of this is 22.4 of this. So we can say that 1 mole of sodium hydrogen carbonate produced 22.4 dm cube of CO2. So what will be the volume of CO2 that will be produced by 1 dm cube of solution B? We all know that 1 dm cube of solution B contains 0.0937 mole. We had already calculated that when we were calculating the molar concentration of sodium hydrogen carbonate. Molar concentration of sodium hydrogen carbonate was already calculated at 0.0937. Therefore, 0.0937 mole of sodium hydrogen carbonate will produce 22.4 over 1 times 0.0937. And when you press your calculator, you are going to arrive at 2.099 dm cube of CO2. I hope you got values from this question solved. If yes, stay tuned on the same channel, Helizchem, where I'll be bringing more interesting topics in chemistry. Helizchem got you covered. Bye.